Hello everyone and welcome to another web development tutorial. Today we will talk about converting your React app into a progressive web app via Create React App. So imagine this for a second. Turning a React app into a progressive web app is like turning your regular backpack into a high-tech, all-terrain jetpack. Imagine your React app as a standard backpack, functional, reliable, and good at carrying your stuff. However, it's just a backpack, limited to the basics of storage and portability. Transforming it into a PWA is like equipping your backpack with a variety of advanced features: solar panels for charging devices, built-in GPS for navigation, weatherproof materials, and jet boosters for fast travel. The upgrade doesn't change its primary function as a backpack. It still carries your things. However, it now offers enhanced capabilities. Like the high-tech backpack, PWAs, or progressive web apps, are designed to be more versatile and resilient. They can function in different conditions, offline capabilities, adapt to various environments responsively, and offer additional functionalities like push notifications that standard web apps don't. Both the backpack and PWAs are steps towards future technologies. In both cases, the fundamental essence remains. A backpack still carries your stuff, and a web app still provides a digital service. But the upgraded versions are better equipped to meet modern needs and technological advancements. Now that we understand PWAs in comparison to Jetpacks, let's cover 10 main benefits to using PWAs. First, offline functionality. PWAs use service workers to operate offline, caching essential assets and data. This is invaluable for ensuring your app remains functional even on unreliable networks. Second, enhanced performance. PWAs load quickly, offering a better user experience, especially for repeat visitors due to efficient asset caching. Third, an app-like interface. PWAs offer a full-screen native app experience on mobile devices, engaging users without the need for a separate mobile device. Fourth, push notifications. This feature keeps users engaged and informed with real-time updates, a must-have for any modern application. Fifth, there's no app store dependency. PWAs bypass traditional app stores, allowing you to push updates and maintain your app directly. Sixth, cross-platform use. PWAs are web-based, so they work across various devices and platforms, simplifying development. Seventh, improved discoverability. PWAs are shareable via URLs and are SEO friendly, enhancing your app's visibility online. Eighth, reduced data usage. For users with limited data plans, PWAs minimize data consumption thanks to their caching capabilities. Ninth, simplified updates and maintenance. With a single code base, PWAs make updates and maintenance much more straightforward. And for the 10th and final one, secure connections. PWAs are served over HTTPS, ensuring user data is transmitted securely. So now that we have a good idea of why, let's look at how by building a hiking blog that hikers can read while out on a trail. Utilizing Node version 20, which is the stable version, let's go ahead and initialize our app by running the command here. This will create a React app that registers a service worker. Let's go over these files briefly. Our first file added is service worker registration. This code imports and registers our service worker. It enables offline capabilities, caching build resources. It includes checks for environment, production, or localhost, and handles updates to the service worker for serving the latest content. Our second file is our service worker script. It uses something called Workbox to pre-cache assets and implements runtime caching for images with stale while revalidate strategy. So we can expect that the PNG we added gets cached without adding any additional methods. To go over briefly, Workbox is a library by the Chrome team that simplifies advanced caching and offline features in service workers. It offers easy tools, help with app performance and resiliency, making the development of progressive web apps more efficient. Next, let's add a custom logo and update the manifest to show that logo. Go ahead and place your logo image in the favicon, which I've included in the repo in the public and source folders. Now update the manifest in your public directory to reflect those changes. Update the name, the short name, update the favicon, the new one, update the logos with the new ones, and also you have to include purpose, any maskable for one of your logos. And maskable is basically, this logo needs to be able to fit in many different shapes of many different shortcuts, and that kind of just depends on what device is being used. And at the bottom you have your theme colors, and the theme color, this will give you your color of your address bar, your app. Then let's update the theme color and background color in the index.html, as well as the new logo names. We'll update those. Update the logo import name in app.js, and then finally register your service worker in your index.js. So go ahead and save all, build and serve your app. Now let's test, but before we do, let's cover how to test PWAs. The first thing we will cover is Lighthouse. Lighthouse is a browser tool to measure performance, accessibility, SEO, and PWA readiness. When checking a web app to see if it's a PWA, it checks two main things. Number one, is it installable, which requires that you have both a manifest and a service worker file, which comes with the command that we ran. Number two, optimizations like standard icons, responsiveness, and theme colors, which I showed you where we updated in the HTML, as well as the manifest. A little note on testing caveats. Because PWAs cache all your assets, making changes to development can be confusing. So when testing a PWA, it's always best to use an incognito window. And if not, making sure you always clear your site data for localhost. Otherwise, you get old application data for future development updates. Now let's test our last updates. You should see the new logo spinning and icon in the tab. You should see both build files and logo in cache storage. Let's install the app via address bar. Now we should expect a desktop shortcut or a mobile shortcut depending on your device. Now since we utilize Create React App Template PWA, you should meet PWA qualifications in Lighthouse. So pull up Incognito, go to the Lighthouse tab and generate a report. And there you have it. Congratulations. We are Progressive Web App approved. Now switch to offline or switch off Wi-Fi and reload your app to check for offline enablement. Okay, everything works as an offline app and we are officially a PWA. So now let's update our app to a blog we will populate fake data with. Below is a basic blog where we fetch fake data via JSON placeholder and render just a very basic blog. And then we update the CSS for a little bit better styling. And just go ahead and copy paste this. This isn't a course on CSS, so we want it to look decent. And now run build and serve. So back to testing. Let's go ahead and test in an incognito window. Fake data should load and display. Now let's toggle status offline and refresh the page. We no longer get data and get a fetch error. So this part of the app is useless offline, but we can cache this as well. So let's update serviceworker.js to cache our API request. The code we are about to add registers a route and a service worker to intercept network request directed at URLs matching the pattern for our endpoint. It employs the network first strategy, which initially attempts to fetch the resource from the network. If the network request fails, it then serves the resource from the cache. With Workbox, in addition to the network first strategy, which we will use today, other caching strategies can be utilized, each with its unique approach. Let's cover the others we aren't currently using so you know your options. Number one, cache first. This strategy prioritizes serving content from from the cache. If the requested resource is available in the cache, it is used immediately. Only if the resource is not in the cache does it attempt to fetch from the network. This approach is ideal for assets that don't change often, like CSS or images, build files, etc. Number 2, network only. This approach always fetches the resource from the network, bypassing the cache entirely. It's useful for requests where up-to-date information is crucial, such as submitting form data. Number 3, cache only. Opposite to network only, this strategy serves resources solely from the cache, never using the network. It's ideal for scenarios where network availability is not guaranteed and the application can function with pre-cached resources. Take a hiking navigation app, for example. Maps are unlikely to change, so this strategy fits well for that scenario. 4th, stale while revalidate. This strategy serves a resource from cache, if available, for immediate use, but simultaneously fetches the latest version from the network in the background. The cache is then updated with the new version for future requests. It's a balance between quick response and ensuring updated content. This approach balances speed and reliability. Each of these strategies offer different benefits and trade-offs depending on the needs of the application and the expected network conditions. But Workbox makes this super easy. So let's go ahead and install Workbox by running this command. And then we'll go ahead and import the required Workbox modules. And they recommend this import scripts. And then third, we'll go ahead and cache the post from the API. Now let's update the service worker and register our post route. And then we go ahead and build and serve. So first, let's check the network tab to see if our data is being controlled by the service worker. And it is. Also, this log from Workbox should also be here in your console. Now click offline and refresh the page. Data should now persist. Congratulations. As you can see, our data works offline. Now that we have cached our fetched data, let's add 3 new features to improve our UX. First thing we'll add is a status header, letting our user know if they're offline or online. Which, this feature is important because you have to let your users know that they may be being served out-of-date content. Number 2, for users who may not know your app is installable, we will add an install button. And this is another feature, just letting your users know, hey, this app does work offline, and it can be a good way for stickiness. Number 3, and last, we'll add an all post header for when all of our posts were last updated, so our users know when they are reading old posts versus not. Now this is ideal if you have, these blog posts are a good example. If you haven't got the most recent blog post, you may want to look at that date, and that date may tell you, hey, I need to refetch all the new blog posts. So first off, in app.js, go ahead and add the logic to detect the online-offline status and display it. And as you can see, we use this built-in navigator.online, and this is kind of a neat way that we can tell if our user is online or not. Now for testing, go ahead and test status by toggling offline in Applications tab, and you're going to have to visit the Chrome App Store to uninstall the app and then test the install button. But the install button only shows if the user hasn't installed it, so it should be a conditional button. Know that this only shows if it's not installed. Check for the existence of the last updated date. And there we have it. Our users can now check out important blog posts off grid. Today we covered a good analogy on how PWAs can enhance our website, 10 benefits of a PWA, and how to actually build one. In summary, converting your React app into a PWA can significantly enhance its performance, user experience, and accessibility. It combines the benefits of the web and native apps while simplifying development and maintenance. Thank you for watching. If you found this tutorial helpful, please like, comment, and subscribe for more web development content. Happy coding.